I will straight away go through the Miller indices, because without knowing the actual concept of the Miller indices, we cannot learn about or we cannot understand Braggs principle. So, to understand this Miller indices, I will represent this Miller indices by MI, Miller indices. Okay? Now you see, first of all, I am drawing a three-dimensional Cartesian coordinate. This is x-axis, this is y-axis, and this one is z-axis. And now I am considering the smallest possible plane. This one, A, B, C, and this plane is actually called unit plane, which is actually the smallest possible plane. Now, you see, if I draw another plane, this one, say, and the intercepts on the x, y and z axis are given like this, and I am naming this plane as P, Q and R. Now you see, we will see that, this is the origin, let me see, and the intercept of the unit plane, that is smallest possible plane, along x-axis, I am taking it as A, that is OB equals to A, OC equals to B, and OA equals to C, say. So, if we find out the intercept along x, y and z axis of the next plane, that is PQR, we will have obviously, OQ along x axis equals to, say, LA, OR equals to MB, and OP equals to NC, where L, M and N are integers. Now, this L, M and N are called Weiss indices. These are called Weiss indices. Weiss indices. So, we are coming to the law of rational indices, law of rational indices, which states that, this law states that any plane larger than ABC, that's unit plane, or any plane having intercepts along x, y and z axis larger than the corresponding intercepts of the unit plane, will always be an integer, or will always have an integral value of the corresponding intercepts of the unit plane, or the smallest possible plane. This is what we call law of rational indices. Now, I am writing the law of rational indices. You see, it says that the intercepts of any plane larger than the unit plane will be always an integer of the corresponding intercepts of the unit plane. Now this is called what we know the law of rational indices. Okay? Now see, suppose I am considering a plane parallel to both z and y axis. The plane only intersects the x axis. So the intercept, this is the origin, the intercept along x axis will have some value, say suppose L, but it is parallel to both z and y axis. This is the plane. This is the plane. Now therefore we see that the Weiss indices, that is the value of the intercept along x axis it is L, along y axis it will be infinity, and along z axis it will also be infinity. So the plane is denoted by the coordinates L, infinity, infinity, which is meaningless, that is, which is undefined. So Weiss indices cannot predict the direction of the plane. That's why a new law had been arised, which is called Miller indices. Now through Miller indices is advantageous because through Miller indices we can find out the direction of the plane and we can define the plane. So now we will see that what is Miller indices. We have already seen the Weiss indices. And now we will see that the Miller indices is the reciprocal. Miller indices will be the reciprocal of Weiss indices. Weiss indices. So what is Miller indices? Miller indices is the reciprocal of Weiss indices. So now we will start studying about the Miller indices. So we have already learned that Weiss indices fails to predict the direction of the plane. Therefore, we have come to the new idea which is called Miller indices. Miller indices. Now, we have already knew that Miller indices is the reciprocal of Weiss indices. Okay, this is the actual idea from which Miller indices had arisen. Now we will show that there are some characteristics of Miller indices. Now we will see the characteristics of Miller indices one by one. First of all, you see that number one, Miller indices will always be an integer. Number two, it will never be fraction. Number 3, it will never be infinity. Number 4, it will not have negative value. So these are the criteria of the Miller indices. We see that through these criteria, especially through this point, number 3, we can see that a plane cannot pass through origin x, y and z. A plane cannot pass through the origin, because if a plane pass through the origin, the Weiss indices will be 0, 0, 0 along x, y and z direction. Therefore, Miller indices will be infinity, 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 which does not mean nothing, because Miller indices can never be infinity. Therefore, we can say that a plane cannot pass through origin. A plane cannot pass through the origin. I think it is clear to you. So, I am going to the next topic here. Therefore, after Miller indices, I like to see how can we find out the Miller indices by considering the Weiss indices in question answer basis. Case number 1, suppose the Weiss indices or the intercepts or Weiss indices is given by A by 2, B and C by 3. Okay? Therefore, the Miller indices of this plane will be the reciprocal of all the threes, which turns out to be 2, 1 and 3. So this is the Miller indices of this plane, because the integer here are 1, half, 1 and 1/3. We have taken the reciprocal and found the Miller indices of this plane given here 2, 1, 3. The second case. Now you see, if the Miller indices is given by, intercepts of a plane is given by x, y, z implies 2b, 3c, 2a, 3b and c respectively. Then what will be the Miller indices of this plane? What will be the Miller indices of this plane? Now Miller indices, before finding out the Miller indices, we have to find out the integers. The integers, I am writing it as I. Integers are 2, 3 and 1 along x, y and z axis respectively. So the reciprocal are half, 1/3 and 1 respectively. This should be the Miller indices. But actually we have already knew that Miller indices cannot have any fractional value. So we have to multiply all the integers, all the reciprocals with the LCM. So the Miller indices will find the value of The resiliency is 6. So 3, 2 and 6. So this is the Miller indices. These are the Miller indices of the corresponding plane denoted by 2A, 3B and C. We have converted these Bayes indices from Bayes indices to Miller indices. Okay. Now next case. Suppose see case number 3. I are provided with intercepts, say A infinity and 1. Okay. Therefore, the reciprocals will be the integers will be 1 infinity. Sorry, here is C. It will be C. 1 infinity 1. So the reciprocal will be, that is Miller indices, will be 1, 0 and 1. Okay. Now the last case, or the next case, number 4. Suppose I have been provided with a plane. I have been provided with a plane, say minus 2b and 3c, say. Therefore, the Bayes indices or integers will be 1, minus 2 and 3. So, the Miller indices will be 1, minus half and 1/3. But we know that Miller indices cannot be fraction, so I will multiply all the integers with the LCM 6. So we'll have the Miller indices as 6, minus 3 and 2. And again we know that Miller indices cannot have any negative sign. So we can write this Miller indices as 6, 3 bar. This negative sign has gone to the top, 3 bar and 2. Now this is the actual Miller indices of the plane given by A, minus 2B and C. So students, today up to this, in the next class of solid state, we'll discuss about how to draw the planes if Miller indices are given, and the reverse one, conversely, we can say that the plane is given and we have to find out the Miller indices of the plane. So for today, goodbye.